So in this video we will be talking about the variables and arrays and pointers. So to declare a variable, I can just simply say dword, which occupies the 32 bits, 4 bytes, and I can just say 22. Now my variable is declared. To access this, we cannot access this one because we don't know the exact memory location of this variable 22. So that's why we assign a value to this. So let's say age. So this age is not exactly a name, but it's a memory address at which this 22 resides. So you can refer to this 22 value using this age. So that is what variable is. So we can also define other variables, like you can also define other types of storages, like signed d word and signed word. So it can take the negative values also. And I can also say prices. So let's say I have some items and their prices. So I will have multiple prices for multiple items. So I want to just store all the prices values. So I will store in a sequence manner: 24 comma and 55 comma 100 comma 69 comma 80. So these numbers are allocated into the memory consecutively, one after the another, each obtaining the 4 bytes, that is of this div. You can also just simply say byte. So if you tell the byte, the maximum value is 255. So you cannot go further that. So byte is 2 power 8. So you cannot go more than that. So that's why it's good way to represent these integer numbers as a dword. Now this is my array. So I can just say now nop and put the breakpoint. Let's go and run this one. Now if I go and access the memory address of age, you can say ampersand age. So it will go to this address of age, base address, and here you can see the value 16. So 16 means in hexadecimal 6 plus 16 into 1, 16 plus 6, 22. So from here onwards, if you go to the 4 bytes, these 4 bytes belongs to the age. You can see here 16 000000. So this is in the Little Indian byte order. If you want to get the actual value, you need to reverse this byte order. So first 000000 and then 16. So the value is 16. And here you can see the immediately after this age, you will get the prices value. So you can see the 18, that is 24, and the 55, 100, and so on. So these variables get will be consecutively side by side. I can say ampersand prices. Now you can see I got directed to this 18, the starting element. If you go up, you can also see this 16. So we are just being shown these prices first value as the starting top. So we just get directed to this one. Now what I can do is I can loop over this one. So I can say prices plus 4. So why 4? Because each element occupies 4 bytes. If I want to access the second element, I need to skip these 4 bytes to get the next value. Okay, so the value was being added. So So it automatically converting that 1 into d word according to this one. But when we are looping over these arrays, in the next video we will be using this ESI register to loop over this. So the next one we are going to discuss is the length of this array, finding the length of this array. So we need to declare a variable immediately after to this array, and storing this 4 bytes. Now we need to use what is called current cursor position. So the current cursor position will be at the ending of this 80, and what you want to do is you need to subtract the prices. So the prices will be pointing to the base address, and the subtraction from the current cursor position to the starting of these prices gives you the length, total size of this array. So let's go and run this one. So we have 5 elements, each takes 4 bytes. If you multiply 5 into 4, the answer is 20 bytes. So you can see the 14 hexadecimal, 4 plus 16, 20 bytes. Now I want to find how many elements are there in this prices array. So I can say divided by 4. Why 4? Because each element occupies 4 bytes. If I go and run this, now I can see 5. So there are 5 elements. I also don't want to divide with 4. If I go and change this one word, now each element occupies only 2 bytes. Now I want to change here also. So I don't want that, because I want to get the size dynamically, size of each element. So what I can do is I can use something called type directive. So if I say type prices, so this type will get the size of single element of this array. So let's go and restart this one. So if I go and say prices run, I will get the value 5. Now let's go and change this devote to word. Let's save this one. Now if I go and restart the program, I should see the same value 5 regardless of this data size, because we are getting the size of each element dynamically. So if I go and restart this one, and let's go to prices run, and now here you can see the value 5. If you did not use this type, you need to put the explicitly the value of single element, that is 2. So let's change back this to d word. So this is how you get the length of an array. And the next one we are going to discuss is the offset. So offset gives the starting offset from this data segment. So if the data segment starts at 4000, so this variable will be stored at the 4000, and this occupies 4 bytes, and this occupies 4 bytes, and after 4 bytes at 4004 or 4003 we will have the prices. So this occupies like 20 bytes. So after this 4023 you will have this prices string. So this offset directive gives you the offset from this data segment. So let's say temp, offset age. Now let's go and run this one. We should see the address of age. Oh, sorry. So you can see if you consider the 4 bytes 00 DA40. So let's go and type this here, 00 DA4000, and now we can see this is the exact value stored here, that is the age variable. Now this is called pointer because it's holding the value of the address of another variable. So here the temp is the pointer. So the pointers in assembly are very straightforward compared to C and C++. So this offset will be used in a functions where we want to pass the address of any variable. In similar way we can get the offset of prices. So let's go and restart that. If you go to this value 0019 4004, okay, I typed another 4 extra, so sorry for that. Now you can see the values, the array here, which we have seen previously. So this is how you declare a pointer, and this offset can also be used for the functions which require address to be passed as a parameter. And the next one is the string array. So the string, we can say name byte. So the each element of the string is a character, and character takes 1 byte. So I can declare like T and E and C and so on, ending by 0. So in this way, if you want to declare a large string, it will be very time consuming. So this is why there is an exception for strings can be concatenated without commas. So I can just say tech 69 YouTube, and the followed by 0. Why 0? Because the 0 is identified as the end of the string. So if I go and run this, okay, the name should be a predefined directive, I guess. So that's why we got the error. And here we can see the tech69 YouTuber. The same way we can define the size of this array. Just like we did with these prices. Now if I go and run this one, and let's go to name one run. So 10 the 16 bytes. And the next one we are going to see are the constants. So I can declare like pizza is equal to 69, like the price of the pizza. Burger is equal to 100. So you can use these constants in the program. So the reason why we are going to use these constants, because if you have to use these values 69 100 in multiple places, so let's say you need to do some operations, so it involves 10 times of these variables. So if you want to change this value, you need to change the 10 times. So instead of that, I can simply say move ex comma pizza, so it will be moved in the value of the 69 in all those 10 places. So you can just simply change this 69 to 70, and all these occurrences of pizza will be replaced by 70. So it will be time saving for us. And we can declare you can copy this one, you can just place this here. So let's say this value is 1, so that we can easily identify in hex. So let's go and run this one. So now you can see the 1 value here, so the value will be replaced here. So let me change this to some 12. Now I should see the value C, A is 10, B 11, C 12. So let's go and run this one. Now you can see the C value here. So you can just use these constants if you want to, if you are using this value in so many places. And the next we are going to see is the size of so the size first we will see the length of, then we will see the size of. Let's say an array 1, and I can also extend my array into multiple lines. So how we can do this is let's say 66 comma 70. Now I can go ahead and say d word, so now this all belongs to the array 1. So these are a continuation of these elements. So let's go and run this one. Now we can see the 1 2 3 4 5 6. So okay, we can get the length as well. So let's run this one. And now we can see we have the 8 elements, 1 2 3 and 5 elements. So we got the size. So you can see this is our single array. Now the length of directive gets the length of this array, but there is a catch. So let's go and see that one. Let's comment out this one. So this length of directive only counts up to this one, up to 3 elements. So now you can see we have seen the value 3. So to get the full length, you need to define like this. You need to delete this one and put the comma here. So these will be continuation for these 3 elements. Now if I go and run this one, I should see the value 8. Now we can see the value 8 is there in this variable array1 length. So this is the better way to define an array. You can also do with the strings. Now I can just simply put a quote and hit enter. Now put some space here, and now this one is also a single array. Now if we go and run this, okay, there should be comma. Let's go and run this one, and let's see the value of name1. Now we can see we got the full name Tech69 YouTuber. Name1 length is the 16 characters as usual, as seen from the previous run. Now you can comment out this one and copy this. Now we should see the exact 16 value in the name length. Okay, I did not put the one, so we can see the exact 16 value in this one. Now there is a size of directive, so this size of is the result of multiplying this length of with the type. Now I should get the value 16 into 1, that is 16. So we get the same value 16. So these are the variables and arrays and the pointers in assembly language.